Agorithm. The EM algorithm is the combination of various unsupervised ML algorithms, such as the k-means clustering algorithm. Being an iterative approach, it consists of two modes. In the first mode, we estimate the missing or latent variables. Hence it is referred to as the expectation/estimation step, E-step. Further, the other mode is used to optimize the parameters of the models so that it can explain the data more clearly. The second mode is known as the maximization step or M-step. Expectation step, E-step. It involves the estimation, guess, of all missing values in the dataset so that after completing this step, there should not be any missing value. Maximization step, M-step. This step involves the use of estimated data in the E-step and updating the parameters. Repeat E-step and M-step until the convergence of the values occurs. The primary goal of the EM algorithm is to use the available observed data of the dataset to estimate the missing data of the latent variables and then use that data to update the values of the parameters in the M step. What is convergence in the EM algorithm? Convergence is defined as the specific situation in probability based on intuition, e.g., if there are two random variables that have very less difference in their probability, then they are known as converged. In other words, whenever the values of given variables are matched with each other, it is called convergence. Steps in EM algorithm. The EM algorithm is completed mainly in 4 steps, which include initialization step, expectation step, maximization step, and convergence step. First step, the very first step is to initialize the parameter values. Further, the system is provided with incomplete observed data with the assumption that data is obtained from a specific model. Second step, this step is known as expectation or E-step, which is used to estimate or guess the values of the missing or incomplete data using the observed data. Further, E-step primarily updates the variables. Third step, this step is known as maximization or M-step, where we use complete data obtained from the second step to update the parameter values. Further, M-step primarily updates the hypothesis. Fourth step, the last step is to check if the values of latent variables are converging or not. If it gets a yes, then stop the process, else, repeat the process from step 2 until the convergence occurs.